HR Teams welcomes you in this session. Yeah, Doctor, we can start, please.
Okay, thank you. Good morning to everyone. My voice is audible. Ma'am, my voice is audible, ma'am.
Yes, is clear.
Okay.
Yeah, it's fine. The presentation is clear.
Okay.
You can start by brief about yourself, then you'll
Okay.
start the topic, please.
Okay. So again, good morning to everyone. I'm Dr. Karthikeyan. I'm working as a lecturer in electronics and telecommunication engineering in the EEE section, Department of Engineering. I have completed my PhD in the field of wireless sensor network, which is almost similar to the IoT now. So I've also done some projects related to this IoT in telemedicine. When I was working in India, I have some scholars. Myself and with my scholars, we have done some projects in telemedicine. So I just want to share some of my experience when we are doing the project with you all. I hope this session is uh, helpful for everyone. So let me start the session with the outline of the presentation. So here, first I would like to start with introduction and why IoT is the right option for telemedicine. Things you should consider before deploying IoT for telemedicine. List of IoT application use cases for telemedicine. Top challenges of IoT in telemedicine. Advantages and disadvantages. IoT trends in healthcare. Future IoT in healthcare. So this is all about to brief about you about what is IoT in telemedicine. So almost most of them we have already have some knowledge related to this IoT. I just wanted to recall all the information. And after completing all this, I would like to share some of my experience when we were developing the project related to this medical things, IoT medical things. So we have done some 3 or 4 projects in which I would like to share one of my project. Okay, since we are limited with 1 hour of time, if possible in the future, I would like to share some more experience. But this today I'm going to share with you only one project, which is nothing but hidden Markov dynamic time warping model for walking speed detection. In short, we can say HMDTW. And finally, we'll summary all this. Okay, so we start with the IoT. So before starting what is IoT and all, I would like to give you some brief about the introduction. The Internet of Things is refers to, in short, we can say IoT refers to the technology that connects physical objects to the internet, while it's a boon for healthcare systems, especially telemedicine. IoT is developing and changing the way healthcare facilities, including remote patient monitoring, and it delivered through existing interconnected technology. So we are just going to use the same IoT infrastructure and we are going to implement the telemedicine things. So if you are looking to integrate the Internet of Things into telemedicine, you need to know more about this technology's potential in detail. That means if you know more about this IoT, implementing telemedicine IoT is simple actually. But I would like to begin with the facts and figures of IoT from market perspective. With an expected 1 trillion US dollar spending on the Internet of Things technology by this year. So this year it is expected to be 1 trillion US dollar. So in which what is a part of this IOMT? Nothing but around 430 million IoT devices in the healthcare segment is going to be installed in this 2022. And the healthcare industry is the largest beneficiary of the Internet of Things. While telemedicine received a new phase, in fact, IoT has streamlined the core concept of telemedicine to provide the best healthcare facilities to people living far off a remote location with no healthcare facilities. So this is the most important thing which we are going to see. And now we'll see what is IoT. IoT is the Internet of Things in general, connects the physical objects world to the internet and enables user to collect, share information in real time. For example, with IoT, you can connect objects such as lights, machines, ACs, fans, almost all the electrical goods we can connect with this IoT and the internet. So what is telemedicine now? Telemedicine is nothing but, even though most of you may be aware of telemedicine, let me give you a brief about the introduction. The core concept of telemedicine is to deliver remote healthcare services to people living in remote areas, especially where there are no healthcare facilities. Besides, it also had a purpose to reduce the burden of hospitals loaded with n number of patients. Okay. Now, why IoT is the right option for telemedicine? Why not we can have some other technology? Even though IoT can be beneficial almost every industry. So nowadays we can say IoT can be used almost all the industry, corporate offices, manufacturing sector, smart home, and so on and so forth. Healthcare is no exception at all. In contrast, healthcare can be the largest beneficiary of it. With IoT, healthcare managers can ensure the growth of telemedicine by grabbing the offer that IoT has to offer. For example, the quality of care, enhanced patient monitoring system, real-time healthcare tracking system, and much more. So even after having so many offering and facilities, what are the benefits of IoT in telemedicine? This is an important concern for most healthcare organizations. So let's glance through your top benefits of IoT in healthcare. So we are going to see some of the important information related to telemedicine. So it supports doctor. So that is the most important thing. Whether it is to access patient data or examine the wound, rash or patient health condition improvement, and the Internet of Things can be the best supporting innovation for doctors. However, doctors also have to face some of the challenges. So when they are going to examine, the doctors will face some issue. What are they? For example, they cannot listen the heartbeat or check blood pressure using IoT technology. So this was before, but recently there are some technology which will help them to check all these things. There are some wearable devices powered by IoT which will play the important role, allowing doctors to access relevant information. Real-time healthcare monitoring. So this is another important thing related to this IOMT. What do you mean by that? If technology is boon for humanity, IoT in healthcare can be the example of it. It has plenty of offering to healthcare, while real-time monitoring is a life-saving feature that IoT delivers to healthcare. Doctors can get patients' health report every second, establishing better and enhanced healthcare facility. Patients wearing a monitoring device will enable doctor and patients to check abnormalities if it happens. Okay, if the patient is wearing these IoT devices, the doctor is enabled to check every second the patient's condition. So this is one of the most important facility we can have with IOMT. So this is the best made for senior citizen. So this is where we have done some project with the help of senior citizens. So this is really disheartening to see many older people struggling to get better medical treatment, even in urban areas. However, with IoT integration, the issue can be resolved successfully. Doctors and hospitals can provide healthcare facilities to senior citizens without letting them leave their home. Technology can help them make their life more comfortable and hassle-free. IoT devices will not only help people, especially senior citizens, improve their health condition, but also it will be a boon for people with disabilities. So not only senior citizens, if the people are having some disabilities, these IoT devices help them better. And before deploying, we have to consider some of the things in telemedicine. So IoT is the need of the hour, we all know, especially in the healthcare sector. However, you can't just get it developed and integrated into your healthcare system, you need to consider certain aspect of it. What are they? The infrastructure, on-site IoT maintenance, security arrangement, device support and testing. So these are all the information we need to concentrate before going to install this IOMT. So we will see one by one. So what is the challenges related to the infrastructure? Even though IoT does not require any complex infrastructure to deploy, you should make sure that there are no lost time hassle. For example, power points, access points for cable, permission for device cabling, no connectivity barrier, proper installation space, and should be ensured earlier to avoid any further glitch. You may also need to have a networking staff who will support you from device installation to management. So these are all the things we need to concentrate with respect to infrastructure. And with respect to on-site IoT maintenance, if you are considering installing IoT technology into your healthcare system, you have to consider its maintenance. Initially, you may not need to spend on its care, but as it grows older, the IoT devices will get damage off, and then maintenance will be needed. So this is the part of maintenance. From on-site, we are able to maintain the IoT devices. It could be a challenge and you may be compelled to hire professional who will look into this matter. However, it will also be helpful to the people who are looking to. Now, the most important things with respect to IoT is security arrangement. IoT works on telecommunication along with internet connection. So this is the most important thing, and hence it is crucial for users to have secure connection. It's really a challenge for healthcare managers to keep patients' identity, health information safe and protected. So there are two things. The first one is PII. PII means patient's identity information. And the second important thing is PHI. Is nothing but patient health information. So these two information should be maintained confidentially. Otherwise, there are going to be some issue because they are highly sensitive information and security is essential during the storage and transmission stage, right? So the security is most important concern. The next thing is device support and testing. You would not take a risk of getting technical glitch since it is related to the human lives. We have to concentrate more on the technical glitch once it is implemented. Therefore, it is essential to have proper testing and ensure tech support to get the seamless result. If IoT devices are not tested, you may fail to achieve user satisfaction. Testing of IoT devices include, there are many testing, but with respect to IoT, we need to concentrate some of these types of testing. For example, connectivity testing, logistic testing is nothing but how the components are connected, whether it's working properly. So this is important thing. And inventory management testing, how we are keeping the things. And finally, life cycle management testing, how many years we can use a particular device. Is nothing but life cycle management testing. And the list of different application use cases for telemedicine. Okay, in IoT, if you are going to use telemedicine, there are many different application. We will see the important applications. The first thing is mobile health. What do you mean by mobile health? IoT has added another feather to M health. In short, mobile health we can say M health. This system that enables doctor to keep track of all vitals, including blood pressure, heartbeat of patient. There are many things. Okay, if you are connected the handheld devices with the patient, the doctors are enabled to see all the informations. The patients, as we have discussed earlier, the challenges that doctors have to face with IoT in case remote monitoring. With IoT integrated with the smart wearable devices, doctors can now quickly get detailed report including the required vitals of the body. With mobile health, handling critical situation will become easy. So the next important thing is reminder, ingestible sensor and devices. What it means? Sometimes or more often patients forget to take medicines timely, especially the elder people. Even doctors get busy with other work, forgetting that they are patients who needed attention. But these all things we can remove by adding this IOMT. With IoT places, the ingestible sensor can keep them regular. What do you mean by ingestible sensor? The sensor is like a tablet. The patient will swallow it so that the doctor can monitor inside organs. And the patients will be reminded to take medicine in time, while doctors will get notification and alert if they have to examine. And finally, we have remote patient monitoring. So this is most important since we have faced the pandemic situation. The patients cannot enter to the hospital most of the time. So the doctor is able to monitor them from their place itself. For example, remote patient monitoring is believed to be the sole reason why IoT was introduced in telemedicine. IoT-enabled devices for patient monitoring ensure that doctors get all necessary information, such as patient health condition, blood pressure level, and so much more remotely. Whereas patients, especially those living far off areas, do not have to come to the hospital physically. So this is the most important thing. So these are the basic use cases through you can come with plenty of IoT app use cases in telemedicine. So these are all some of the basic use cases, and there are many n number of use cases we can develop by using this IoT in telemedicine. So what are the challenges we are going to face when you are going to implement this in the healthcare system? When you are going to implement this IoT into the healthcare system, we are also going to face some of the issues. Okay, a saying goes, the IoT value is never greater than what management is prepared to do with it. It's nothing but if the management wants something, the IoT has to help them. We cannot implement all the technology together, what the management needs. So that is the most important thing. So more than the technology, what the management needs. So here we are facing, these are all the issues. The first one is unauthorized access. It needs to vulnerability. What it means? When it comes to IoT in telemedicine, having a robust security model system is a need of the hour. So we need to have the security system should be proper. So this is the most important thing. If you don't have that, it might invite hackers and online robbers to peep through your internal affairs. So the online hackers can easily access your data, and that may not be good for your healthcare facilities. So we have discussed a little bit about challenges regarding IoT in the telemedicine earlier in the presentation. For example, collecting data, exploring the authenticity of it, managing of data. So more of it is nothing but data. So we have to maintain the secure data process inside the system. So when you go for the security at stack, IoT, if not protected well, will be vulnerable to hack. What if even single patient data is hacked? It will keep the centralized system at stake. For example, if some of the hackers steal their data, they are able to steal the whole system. So this will affect the total healthcare system. You may not be able to control the situation efficiently. You may not be able to control the situation efficiently. So now we can have some other alternative. However, the proper calculation and the precautions and timely maintenance along with team support can help you avoid such issues. So the next thing is healthcare policies and transformations. So even though world healthcare is going through a transition, so they are trying to implement all these technologies into the healthcare sector. It should be consistent across all states and all countries. For example, many countries follows outdated healthcare system and regulations. There we cannot implement all these technologies together, which may create barriers in integration of technology. So this is also one of the important concern we have to check. So before going to check the case study, we will see the advantages and disadvantages also. So what are all the advantages? Considering the above mentioned challenges, we are going to see some of the advantages. The first one is all around technological enhancement. The all-consuming connection of healthcare devices and data, centralization brings many significant benefits to the table, such as rendering hospital visits unnecessary. So this is one of the important thing. We no need to visit for a small issues. Passively accumulating and deeply analyzing important healthcare data. So we can analyze the healthcare data from the remote place. We can give the solution. We have already pondered on all these advanced tech capacities grow enough. The IOMT provides space for fantastic long-term innovations. So this is one of the important things. The second advantage is cost saving. One of the greatest advantage it is actually because efficient autonomous system will cost less to manage and employ in long run. So autonomously the system will be managed so we can reduce the human resource. Things are even better when it comes to patient cost saving due to fewer hospital journeys. So no need to visit the hospital. It will reduce the cost. Also the diagnostics and the treatment. So what about the accessibility? So this is also coming under the advantage. Doctors can view all the necessary data and command and check the real-time patient condition without leaving their office. So the doctors have the access from their working place itself. So if the patient are unable to move to their place, they can check all their data. And what about the disadvantages? So there are some disadvantages also. The first thing is privacy. Privacy can be potentially undermined. It's nothing but, as we have already mentioned, systems get hacked. Lot of attention will need to be focused on data security, which requires significant additional spending. So when we are concentrating more on security, we need to spend a lot of amount in it. So the next thing is unauthorized access to centralization. There is a chance that dishonest interlopers may access centralized system and realize some cruel intention. So if they are having some cruel intention, they may destroy the system. And finally, global healthcare regulations. As we have discussed already, international health administration are already issuing guidelines that must be strictly followed by government medical establishment, integrating the IoT in their workflow. So there is a proper set rules already available to develop the IoT model in the healthcare sectors. So these may restrict possible capacities to some extent. So when you are going to follow these rules and regulation, some of the facilities we cannot provide in all the places. So these are all some of the disadvantages with respect to this IOMT. What is the trend now? IoT trend in telemedicine. What is the current trend in the telemedicine? So there are several IOMT trends implemented by majorities of startups worldwide. The first thing is wearable wearable devices. So these are all continue to the top of the market till today. So major mobile technology providers like Apple and Android are enhancing and updating their authentic wearables. In day-to-day life, we are also using some of the wearable things. For example, walking when you are wearing the watch, which will show you the heartbeat sensor, heartbeat monitoring level, almost all the information we can get it from that. So here, when we add all this, and the rest of the world is not shy to follow the tendency. So there are numerous wearable things coming to the market nowadays. So the next important thing is surgical robot become a common reality. This AI powered, AI is nothing but we all know artificial intelligence powered robotic surgical means show to the more precise than real doctors. So here the notable thing is it is more precise than the real doctors on more than one occasion. So in the future, these IoT devices are going to do almost all the surgeries. There are still limitations and risk involved in this. but the technology is definitely in the spotlight and it is looking to become more widespread in the near future. So this is one of the important things. And finally, one more thing is integration of other prominent technologies with IoT expands the horizon. For example, this artificial intelligence and the augmented reality, machine learning, big data, blockchain, and smart contracts. So these are all some recent technologies. We can also include all these technologies to fuel up and expand the IoT power and even further. AI is already better and far more precise in predicting for one instance. For example, there are something we want to predict before. For example, cancer. With IoT integrated AI device can predict these type of diseases also in the future. So these are all some important features. So what is the future of IoT in healthcare? What is the future of IoT in healthcare? In 2020, almost all the hospital will deploy this IoT devices. The M-Health is nothing but mobile health as a regular common thing on a global scale and reduced physical visits to hospital. So these are all some future thing. This is only an approximate picture of IoT success. Most of them are either implementing major IoT techniques and capabilities or alternatively have enhanced parts of that are their calibration stage. So still most of the IoT enabled devices are in calibration stage. Once it is implemented, it will be like almost AI enabled system in almost all the healthcare system. Soon in at the end of 2022 is going to happen. It is estimated that the install base of IoT devices healthcare will be more than 430 million units by the end of 2022. So these are all some of the insights related to IoT in healthcare sector. So now we will see one case study. So before going to start the case study, I would like to share something related to this. We have developed this model, myself and my scholar. When we are in India, we have developed this model and we have published this work in the renowned journal. I would like to share some of the points related to this. So this model named as Hidden Markov Dynamic Time Warping Model for Walking Speed Detection. In short, we can say HMDTW. For example, injuries due to unbalanced walk are common for elder persons. Okay, unbalanced walk are common for elder persons, and it is a major health issue present all over the world. So we have taken this issue. We wanted to give some solution for this. In some cases, these injuries leads to sudden death as a heart attack, and a survey reports that more than 2% of elder persons are dying due to unbalanced walking and resulting injuries leads to death. That's why we have taken this issue seriously and we are trying to give some uh, cases related to this. For example, the fear of falling while walking due to nerve issues sometimes is due to stroke and it is called a cautious gait. It is called a cautious gait. So these patients may lose their stride length and the gait velocity and fall down easily at a fraction of seconds. We will see what is stride length, gait velocity and all. So we have taken this and we have provided some solution for this. So it is essential to identify the patient for predicting falls based on their gait characteristics. To devise efficient mathematical modeling of gait analysis for identification of lifestyle or physically challenged person. Not only the elderly person, we have also considered the physically challenged persons to detect any deviation from normal walking pattern to given alarm. So when the system finds there is a deviation from the normal walking pattern, it will give an alarm. Inefficient and select appropriate choice of body wearable sensor which are not burdensome. So when we are trying to give the solution for this, we are also concentrating more on the wearable sensors. So when we design the inefficient sensor, they are unable to wear, again it becomes the burden for them. Then the final thing is integration of gait analysis and IoT for fall prediction and fall detection. Not only prediction and also the detection we have found. So what is the methodology? What is the methodology related to this? To implement an effective yearly prediction and detection system of fall physically challenged person using concept of gait analysis. Efficiency has been imported to the proposed model by optimizing various attributes that relate to the efficient gait analysis through concentration of nature-inspired algorithm. So we have developed an algorithm which is named as nature-inspired algorithm. So here we have seen some of the information related to the falling scenarios. Falling scenarios. So in this diagram you can see what are the different things which will cause the falling of elderly person or differently abled persons. For example, you can see from slipping, tripping and stumbling. In the home, it happens most of the time. So we have taken some 3,500 samples in which this is the most important factor which gives the falling to the elderly persons. So some more things also you can see in this. Other falls on the same level on from the stairs or steps, fall involving bed. So these are all the things in which the most important thing we have concentrated is slipping, tripping and stumbling. And also with two different scenarios. One is from home, the other is from residential institutions. If there is a residential institution, there are people to take care of them. So the falling level is almost reduced. Right. So here, what do you mean by the gait analysis? What do you mean by gait? I just want to give you some brief about it. It's a schematic study of human motion. Gait analysis is nothing but schematic study of human motion, especially the walking or running. It is implemented by eye and brain of observer augmented with instrumentation. So we have taken how it is oriented with eye and the brain. And finally, the instrumentation serves to measure body movements mechanism and activities of muscles. When we develop the sensor, we wanted to check the body movement mechanics as well as the activities of the muscles. Okay, if the muscles are having some issue, it will give the alarm to the person. So this is nothing but the gait cycle. So here you can see a normal person is walking. So we want to check when the normal person is walking, what are all the different posture he is having. Okay, and we have developed this model by checking all the postures when the person is walking. So you can see here, this is heel strike, loading response, mid stance, terminal stance, pre-swing. In all these things, this particular person will not fall down because he is giving a proper distance between two legs and also is a proper walking style. So what are all the improper walking style? So that is also we have developed model that we will see in the next slides. So here you can see what is step length, what is stride length. So by using all these values, we can predict whether the person is going to fall down or not. So here you can see these are all the different models. The person is having some issue in the walking. So these are all the models we have seen, different types of gait. Gait is nothing but walking model. The first one is a normal gait. If the normal person is walking, this is the footstep for them. But if the person is having some issues, the footsteps are different. The first one is spastic parapletic gait. What do you mean by that? Parapletic gait is nothing but partial paralysis of both legs. If the person is having paralysis in the both leg, his walking style will be like this. The second one, B. It is characterized by progressive weakness and spasms in the legs. Symptoms can start anytime in life. Most people diagnosed with paraplegic will eventually have difficulty walking and will also see changes in their gait. So the gait is nothing but the way of walking. And the next thing is the C. The third one is cerebellar ataxia gait. So this is nothing but a clinical feature of cerebellar ataxia gait usually include a widened base, undead lines and irregularity of steps and lateral being. Locomotion is individual with cerebellar ataxia is characterized by significantly reduced strength, frequently with prolonged stance and double limb support. You can see with the double limb support he is walking. So this is actually prolonged. Also, there is no proper direction of walking. So this is also one of the disease in the walking style. And the third one is Parkinsonal gait. Parkinsonal gait is a type of gait exhibited by patients suffering from Parkinson's disease. It is often described by people with Parkinson's as a feeling like being stuck in place, being stuck in place when initiating a step or turning and can increase the risk of falling. So this is also one of the issue while walking. So for these persons, when they wear the persons, those who are having this type of issue, when they wear the sensors, we are able to monitor them. If they are going to fall down, before that, we can give them the alarm. We can give them the alarm. So we were trying to give some of the solution for them. We are trying to give some of the solution for them. So we have developed this model here. So what are the fall prediction and prevention? What are the things we need to monitor? When we take in physiology, so here we need to monitor these things. So these sensor we have to take ECG, electrocardiogram, EMG, electromyography, blood pressure, GSR. GSR is nothing but galvanic skin response. It is also known as skin conductance. It refers to change in sweat gland activity. When the person is unable to walk or they are having some issue, their sweat gland is having some issue. So it will induce the sensor and it will give the alert. So this is one of the sensor we have included in it. And here, what are the fall factor which will monitor? The first one will monitor neuromuscular noise, heartbeat, skin electrical characteristics. What do you mean by neuromuscular disorder? Neuromuscular disorder is nothing but is a very broad term encompassing a range of condition of the impair of functioning of the muscles. If the if the person's muscle is having some issue, this particular sensor will predict and it will give the alarm. So these are all the sensor and fall factors we have developed. And also when it is connected, what are all the sensors will give the alarm? So these are all sensors. Here you can see the accelerator, gyroscope, motion sensor, piezoelectric sensor. And also we have maintained the user profile, his walking velocity, his acceleration, tilt angle, phase transition, foot state, stability and symmetry. So these informations will be recorded in the system. So here you can see some of the sensor. Gyroscope sensor is a device that can measure and maintain the orientation and angular velocity of an object. So if the person is wearing the sensor with the accelerometer, we can see his orientation, how he is walking. He is properly walking, his orientation is correct or not, everything we can monitor by having the accelerometer or gyroscope. So this is the way the person is wearing. You can see these are all the sensors the person is wearing. From the foot, this sensor. It is planted in the foot. It's like a shoe. The shoe itself they can wear. And in the hip, they are wearing the sensor placed in the gait aid device. Okay. So these sensors will give the information through any wireless technology. Here this source is a Bluetooth technology. From this information will be transferred to the mobile phone. We all know mobile phone have the internet connection. From the internet, this person can be monitored anywhere from the world. So this is a short explanation for internet technology which is implemented in medical things. Okay, you can see this person is wearing. From this, we can get all the related information for the person. Is having any disabilities related to his walking style. So in this is a model. So what are the things that are already available? For example, the gait analysis, only the gait motion, movement classification is already available. Gait recognition, how he is walking, walking style, which is also already available, and the activity recognition. So these are all related to movement classification, how he is walking, that's it. Only they have classified it. And movement measurement. So there are some research already developed to measure the movement, how the upper limb is moving, lower limb is moving, other limbs and other parts of the body. So these researchers already they have developed it, and we have just combined all this and we have provided a solution for the falling, and we have also predicted that. So this is the model we have developed. This is a block diagram you are seeing. A simple gait recognition process is illustrated in this. And the process starts from the identifying the human gait. I have already mentioned we have to identify which type of disease he is having. So this is the first part. Then we have to collect the data. It's nothing but data acquisition. This data acquisition collects the preliminary information, and by using future representation, the gait features are summarized. So here we have just collected the data from the person. And using the dimensional reduction process. So by using some of the image process technology, we can use and select a proper data from that. Between the normal gait and the abnormal gait is observed. Okay, after getting the data. Then this data will be given to the next block. This block will take only the needed information. The unwanted information will be removed from this. And finally, we are doing the classification in the first part. What do you mean by classification? Here we have discovered whether the person is having which type of disease, which type of walking pattern. So that we have discovered in this first step. After knowing, then we are also having the sensors which are connected in the person's leg. From the sensor, we are getting the information through any wireless medium. This will be transferred through the Internet of Technology. So here, this data will be processed by using any processor, and it will be given to the data pre-processing. Then the segmentation done in the next step. What do you mean by segmentation is nothing but using image processing technology, we have taken the needed information. The unwanted information will be removed in this phase. And the in the next step, we are incorporating DTW. Is nothing but this DTW is nothing but dynamic time warping algorithm. This dynamic time warping algorithm is already available. By using that, we are extracting the feature, and this will be given to the detection of gate details. And finally, which will be transferred through the internet to the data handling cloud. So from there itself, we can access the data. We can find whether the person is having any issue, or the next step is going to happen, whether he is going to fall down or not. So this information we can predict earlier by using this particular method. So what is the mathematical model we are using to find this? What is the mathematical model we are using to find this? So here, the Euclidean distance between 2 points in either plane or three-dimensional space measure the length of the segment connecting 2 points. So this particular equation will give you the length between two steps. We know that from the two legs, when we measure the length, we can find the stride length of the patient. We can find the stride length of the patient. So this is one of the input to know whether the person is having any disabilities. So here most of the representing distance are 2 points. The comparison of normal gait and the abnormal gait is performed in two equations. So when we have the sensitivity and the specificity, we are able to measure or we are able to understand whether the person is having inability or not. So from this mathematical formulation, there are many mathematical modulations, there are many equations. I have just given one of them to understand the stride length. What do you mean by stride length? And now we came into the conclusion. So finally, what we have concluded after developing the model. This is the model combination of hidden Markov model and adaptive dynamic time warping model for identification of physically challenged person and disabled person from crowded area so that an alert informs the status of patient through communication devices. So without connecting any devices, when we see the patient walking style, by having the video, from the video itself, by using the image processing technology, we are able to identify whether the person is going to fall down or not. Okay, if there is a crowd, the person is walking inside the crowd, we are able to measure whether the person is going to fall down or not by using this particular technology. And this model prevents the person from falling and predicts the fall ratio using the proposed mathematical model. From the proposed mathematical model, we are able to identify the stride length. If the stride length is varying from the normal gait, then we are able to identify this person is going to fall down. And finally, the classification results are sent to the related person through IoT architecture, and also IoT is used to collect the information from the sensor. Once we found the person is having the issue, then we can place some sensor with him. From the sensor, we are able to receive the information and we can send them information that you are going to fall down. So this type of prediction we can make. And this gait identification model is suitable for elder person and persons who are affected with walking disabilities so that proper alert and medication will be provided within the short duration of fall time. Further work in this area can be carried out better classification modeling along with optimization for analyzing. So we are also trying to do further modeling with related to the available researches. So finally the summary. So let us emphasize once more that the IoT can be nothing short of a revolution in the field as important on the global scale as healthcare. There are still many difficulties, peculiarities, and technological obstacles to overcome. And even though there are currently downsides as well as advantages to the concept, things seems to go very well these technological innovations. We are pretty confident that if you ask most medical professionals about the opinion on the subject, they will say that full IoT integration and adaptation is the only logical way of development of advanced medical of the future. With that being said, enjoy the life-saving health improving fruits of the massive technological progress. These are all the database we have used to develop the model. These are all the references. Thank you all for your patient listening.
Thank you, Doctor. Thanks,
Thank you,
everybody.
sir. It's a very nice talk. Thank you, sir.
Thank you,
Thank
sir.
you.
Thank you. Thank you.
Thanks, everybody. If you have any question or doubt, please, you can ask. Anyone has questions? Maybe nobody, Doctor. Okay, anyone? anyway, thank you, Doctor, again. Thanks, everybody,
Thank you,
for
ma'am.
attending this session. Just I want to remind you that the feedback will be sent at the end of this month. So all sessions on the end of the month, we're going to send the feedback. You should to fill that feedback, and immediately your certificate will be uploaded in your CV, in your PC. And for June, we have many sessions, so be close from the training page. And if anyone want to sharing some topics or any idea, so please email me. Thanks everybody again. Have a nice day.
Thank you, ma'am.